I am Dr. Pavitra Bharadwaj and I am Associate Professor in the Department of Computer Science at Jesus and Mary College, University of Delhi. So friends, we have been taking up different topics which are related to the discipline of computer science and those topics which are relevant for the students who are taking undergraduate level and postgraduate level courses in computer science. So we have talked about various topics in this different series of our lectures in this program. And in the last couple of lectures, we have been talking about the most recent and the most sought after field in computer science in today's world, that is data mining, which is of course in line with the trend of today, that is data sciences. Everybody wants to learn about this, and we have discussed a lot about the discipline of data mining, and what are the different aspects related to the process which is used for mining of data. So in continuation with our previous lectures, today again we are going to talk about data pre-processing. So as we all agree that the data which is collected from the source is actually not ready data, it is not suitable data for putting into the data mining algorithm. So there is you need to prepare the data in different formats, in different ways, so that it can be used optimally and most efficiently in your data mining algorithms. Right. So, and we also understand that different data mining algorithms, they have different kinds of requirements of input data that they are going to use to give out the desired output result. And also in addition to this, we also understand that the quality of the input data is going to definitely affect or determine the quality of the final outcome of the data mining algorithm or the data mining procedure that we are going to do. So in this regard, we are looking at data pre-processing, that is how to prepare the data so that it can become most suitable for your data mining algorithm, whatever you are using. So we were talking about different types of techniques, like we were talking about sampling techniques, we were talking about clustering techniques, by way of which we can pre-process the data, or we can sort of make the data more conducive for the algorithm. Another very important aspect of data pre-processing is called dimensionality reduction. Right. Now what is dimensionality? Dimensionality basically means the number of attributes. If you remember, in the previous lectures we had discussed that dimensions means the number of attribute that a data object possesses, right. So dimensionality means what are the different types of features that the data object is having, right. So every object will have specific number of features or specific number of attributes, and that is known as the dimensionality of it. Now sometimes what we see is that there are data sets where the number of features is extremely large. Like for example, if we look at a set of documents and we are looking at the number of times a particular word is appearing in that document. Now if we look at this data set, it is going to be a huge data set, because it's going to have so many components, because the frequency of each number of times a particular word is occurring is going to be a huge data set, right. Another example could be if you are looking at the daily closing price of stocks over a period of 30 years, right. So if we are looking at this, the attributes will be the prices on the specific days, and again the number of days in 30 years, so it is going to run in thousands. So such kind of data which has got such high dimensionality, which is having so many features or so many attributes for that matter, this needs to be reduced. The number of attributes in this data needs to be reduced, right, so that it becomes more conducive for the algorithm, for the data mining process, right. So the reduction of dimensionality can be done by selecting the attributes which are a subset of the old attributes, right. There are multiple ways in which dimensionality reduction can be done. right. So we can reduce the number of dimensions by creating new attributes or new dimensions which are a combination of the old dimensions, or we can have a selection of a few attributes, that is we are only considering a few attributes and we are just leaving out the redundant attributes, right. Or we attach some kind of weightage to each attribute and we only look at those attributes which are having a higher weightage than the ones which are having a lower weightage. So different processes can be used for dimensionality reduction, different approaches can be adopted for reducing the number of attributes. But the important aspect is that this process is very, very vital, because it gives a number of benefits for the data mining process, right, because there are many algorithms which will work best when the number of attributes in the data is lower. So if you have enormous number of attributes, then that algorithm may not function as efficiently as it is meant to function. Another benefit of dimensionality reduction is that it will make the model more understandable, right, because when your model is going to have fewer attributes, then definitely it will be easier, it will be a simpler model to understand. Also, it will allow the data to be more easily visualized, right, and then of course the amount of time and memory requirement for the algorithm will also be reduced when you have a reduction in dimensionality. So all these features, they are a very good motivation, they are a very good source of advantage which will lead to the data analyst in trying to reduce the number of dimensions, right, because there is a very common phrase which is used in data sciences, that is called the curse of dimensionality. So curse of dimensionality basically is the phenomena that many types of data analysis become significantly hard as the dimensionality increases, right. So when the dimensionality of your data increases, the data becomes increasingly sparse in the space that it occupies, right. So the data objects that are under observation, they are not representative of the sample, because you cannot really club them under one sample, you cannot actually aggregate them, you cannot actually cluster them. Because of the number of attributes, the entire data becomes very, very distributed over the space, right. So therefore classification and clustering will become very difficult, because there will be difference in the density and in the distance between the points which are critical for clustering. So therefore the entire exercise of clustering, or maybe finding a common attribute and finding a common value for classification, assigning a class to all the objects, will become very, very difficult, right. So therefore if it is a high dimensional data, it is imperative that the dimensions are reduced, so that we get good quality results from classification and clustering also of the database, right. So in this case now further we go that once we understand that what is dimensionality and what is the need for dimensionality and what is the repercussion on the various techniques and algorithms that we are using for dimensionality, we now see and look at the different ways in which dimensionality reduction can be carried out. So there are different processes, there are different approaches for this. The first approach is feature subset selection, right. So feature, dimension, attribute, they are all basically meaning the same thing here, they are being used as synonyms here, right. So feature subset selection means that we are trying to reduce the dimensionality by using only a subset of the features. That is, we are not using the complete set of attribute, but we are picking or we are selecting only some of the attributes, and the redundant ones or the irrelevant ones are being ignored, they are being not being considered, right. Now there can be a question here that certain important information might get lost if you are just not looking at certain attributes out of the data set. But actually this is not the case, because what we are not considering or what we are ignoring are only those features which are redundant and which are not very useful, right. So whatever information is critical for the analysis has to be retained, only the irrelevant portions of the data are to be removed, right. So the feature subset selection basically is done on redundant data sets, on redundant attributes, right, which are duplicate. So all of the information contained in one or more than one attributes, they are irrelevant, that is features contain almost no useful information for the data mining task at hand, and which are redundant as well as irrelevant. That is, these features, they reduce classification accuracy and the quality of the clusters that are found. Like for example, I can give you an example. If we want to look at the grades, the average grades of the students studying in a class for the past say 7 or 10 years. Now in this case, the data set might contain the student identification information as well as their grades, right. Now here the student identification information, like the student ID or whatever, is not relevant for the analysis, because we are not looking at individual type of information, we are looking at a conglomerate of information, we are looking at a cluster of information. So here the student ID will become very, very irrelevant. So it is very important that how we select the best subset of the features which are frequently requiring a systematic approach. So in order to choose that which feature to keep for analysis and which feature to remove or to just let go is also very important decision, because if by mistake you leave a feature which was actually determining some information, which was carrying some correlation information, then that needs to be taken care of, right. So another example could be that if we in a database, how we see that there is redundant information. So like for example, we have the product information database, right. We have a data set in which the data about products, cost and the sales tax has been stored. Now if we know the purchase price of a particular item, then we can easily calculate the sales tax. So here one of these becomes the redundant information. So we do not need to look at the sales tax figure, because we have the purchase price and we can easily compute the sales tax. So likewise we can have irrelevant features, we can have redundant features which we need to ignore while we are selecting the features, right. Now what is the ideal approach to selecting a feature? That is, we try all possible subsets of features as input to the algorithm which we are going to use in the data mining task, and then we take the subset that produces the best result, right. So this is a very, very comprehensive approach, because we are looking at all the attributes and all the various possible combinations of features which can be given to the data mining algorithm. So this has the advantage of reflecting the objective and bias of the data mining algorithm that will eventually be used. So this is advantageous, but the problem will be that the number of subsets which will be created using this approach will be very high, right, because if we have a data set which has got n attribute, right. So then 2 raised to the power n subsets will be created. So this approach basically, it may be very comprehensive, it may be very precise, but it is not practical. Okay, this strategy is not practical. So what are the other options which can be used for feature selection? So there are 3 options which are used here. First is embedded, second is the filter, and third is the wrapper approach, right. So embedded approach, filter approach and wrapper approach. Now this basically, this embedded, filter and wrapper, they are looked at in terms of with the perspective of the data mining algorithm, right. So embedded, basically embedded approach means that feature selection will be occurring naturally as part of the data mining algorithm. So feature selection has been embedded in the data mining algorithm, right. So specifically during the operation of the data mining algorithm, the algorithm will itself decide which attributes to use and which to ignore. So there is no human intervention in this. It is the role of the algorithm to choose the appropriate features to be selected or to be ignored. The second approach is the filter approach, in which features are selected before the algorithm is used, right. So now this can be having some we use some experience, we use an approach which is independent of the data mining task. So like for example, we will take those features which has got the minimum correlation. So if two features in the data set have got the minimum correlation, it will mean that those are non-redundant features and both the features need to be included in the data mining process, right. But if two features, they are showing strong correlation, it means that there is some kind of redundancy of information which is existing, and therefore one of these features may be ignored. The third approach is actually a wrapper approach. Wrapper basically here means a cover. So what we are doing, that we are using the target data mining algorithm as a black box, right. So it is not it is not known to us that how internally the data mining algorithm will find the best subset of attribute, right. So we had discussed that there is an ideal algorithm which will itself find the best set of features. Here it is not going to enumerate all the possible subsets, but it will simply select the best possible subset that it feels, right. So it is the embedded approach will give us all the possible subsets which were possible, and we can use the one which gives the best result. In wrapper, it is not going to reveal that, it is simply going to pick up the best feature, the best subset, and it is going to use it. So this is the approach of feature selection. That is how the algorithms or how the data analyst can choose only a few features out of the available features, so as to reduce the dimensionality of the data set. The second approach can be the feature weighting approach. Now feature weighting approach basically is an alternative to keeping or eliminating features. So what we are doing, instead of just choosing which feature to remain and which feature to ignore, we assign weight to the features, right. So the more important features are given higher weights, the less important features are given lower weight. Now in this case, actually it is very important that the person who is assigning the weights has the domain knowledge of the data set, because only then the person can choose that which feature will be more important and which feature will be less important. So the weights which are assigned based on domain knowledge or about the relative information, they can also be sometimes determined automatically. So basically it is done through domain knowledge only, but it can also be automated to a certain degree if the domain knowledge is incorporated into the data mining algorithm. So features which have larger weights will play a more important role in the model, because they are going to be incorporated in the model. So this approach is used up to a limited extent. The more commonly used approach is the feature creation approach. So first we said that we are selecting the feature, then we said that we are selecting the feature, but it is based on a value, that is the weight which is being assigned. Now we are looking at another way of reducing the number of features, that is by creating the new attributes, new set of attributes from the original attribute, right. So the new set of attribute will capture the important information in the data set much more effectively. So instead of having multiple attributes, we are going to create new attributes which will be smaller than the number of original attributes. So, this is another way in which we are going to reduce their number. So, two important methodologies will be used for creating these new attributes. The first methodology is feature extraction, and second methodology is mapping the data to a new space. So, two ways we will be using for creating of new feature. So, the first technique which we use for feature creation will be feature extraction, right. So, we all understand that creation of new set of features from the original raw data is known as feature extraction or feature creation also, right. Now, for example, if we have a set of photographs where each photograph is to be classified according to whether it contains a human face or not, right. Now, it's interesting to note that the original photograph or the original data set will only have a mass of pixels, right. Now, from this mass of pixels, it has to identify whether there exists a human face or not in the pattern of pixels which are there. So, there will be certain lines, certain edges, certain curves which are represented in those pixels, which will help the algorithm identify that kind of a clustering of pixels is happening which will represent a human face. So, using that information, it will try to extract the pixels, it will try to extract the features which are revealing the attributes of a human face. Now, this type of approach of feature extraction from a pre-existing data is very difficult, and it is it cannot be used very commonly, right, because it is highly specific to a particular domain. Especially it can be used in fields like image processing, where various features and techniques are used to extract, and these have been developed over a period of time, right. But to other fields, of course, the feature extraction will have very limited applicability. It will have limited applicability for other fields, but definitely in the field of image processing, this kind of image feature extraction has played very crucial and important role. So, we will be continuing in the next topic in the next lecture. Till then, please keep watching CEC. Thank you.